Today, our chapter is Atomic and Molecular Structure Theories of Bonding. To know how the atom is being constructed, right from the centuries, the scientists are being started to investigate that. In that scenario, the first experiment has been done by Democritus in 440 BC. He is the scientist who started thinking about how substances are being made. He said that the substances are being made up of a tiny particles, undivided particles called as atoms. He is a Greek scientist, and in Greek the atom means indivisible. He started his discussion by saying the substances are made up of tiny particles called as atoms, and these atoms are being not to be divided or indivisible. And then throughout the centuries, none of the scientists has been given a proper idea or proper guidelines to know what exactly there inside the atom or what the substances are being made up of. This Democritus scientist, even he said that the atoms will combine to another atom in an exact proportionate to form the substances. So if we convert this into an example, he literally said that two hydrogen atoms are combined with one oxygen to form a substance called as H2O, like what we will call now it is a molecule. And then throughout the centuries, his theory has been untouched by the so many scientists. And then later on stages in recent century, in 1776, John Dalton has started investigating what exactly the Democritus said. Then he started his experiment and he said that even he agreed with the same thing, the atoms will combine with the definite proportions to form a molecule. And then he said that he has done an experiment to prove that what exactly these substances are made up of again. And he concluded that the atoms can be divisible, or he said that the atoms have subatomic particles. And soon after, J.J. Thomson in the year 1897, he has done an experiment called as the cathode ray experiment. Everybody is aware that this cathode experiment is made up of the negatively charged particles. And we have seen the same thing even in our schooling. So cathode ray experiment says that when a cathode ray is being passed through a charged area, the deflection is being seen. These cathode rays are being deflected towards the positively charged area, and these are being reflected by the negatively charged electrode. So he concluded that the atoms are made up of tiny particles are called as corpuscles. And then he coined that and he said that subatomic particles are either negatively charged and positively charged like neutrons, like protons, but he failed to explain how these are being there in an atom. Then you know that it is a plum pudding type of arrangements he explained to the atom. And then in the later on stages, Rutherford in the year 1909 he started the experiments on positively charged particles. He has done the gold foil experiment. Gold foil experiment. In this gold foil experiment, he observed that he has passed a positively charged rays into a tiny, thin gold foil, and he observed that the atom is not like a plum puddings, like the electrons are being scattered throughout the atom, but rather the most of the mass, the most of the charge is being centered at the nucleus, and most of the atom is vacant or empty. And he coined the name as nucleus, where the positively charged particles will be there at the nucleus, and the mass of the atom is centered at the nucleus. And then later on stages, Niels Bohr has been come up with the Bohr's atomic model of hydrogen, and he explained that the electrons revolve around the nucleus in a definite orbital. Rather, Rutherford explained that the electrons will rotate around the nucleus in a spherical manner, and one or the other time these electrons will come and they will collide at the center. And Niels Bohr has explained what the Rutherford said is not exactly correct, and he said that electrons will revolve around the nucleus in a definite path, and he coined the name them as the orbitals. So from the days, it is being observed that in an atom where the positive charge is present and where the negative charge is present. And after the Niels Bohr experiment on the single electron system like hydrogen, he successfully explained the energy levels of the electron and where the nucleus is present, and if we increase the energies of the electron and how it is been going to the higher energy levels and how it is been coming back to its normal ground state situation by emitting the radiation. So the Rutherford said that electrons will give the radiations to the surroundings. But Niels Bohr has disagreed with this continuous emission of the radiation, but rather he explained that the electrons will revolve around the nucleus, and whenever they get enough energy, they will gain the energy and they will go to the higher energy levels. And he successfully explained the angular momentum of the electron, like he has said that the angular momentum MVR is the angular momentum of an electron, and he said that the angular momentum of the electron will be quantized, and it will give this energy will be quantized at the multiple of h by 2 pi. This clearly explains the energy levels of the hydrogen atom of different energy levels. Niels Bohr successfully explained the electrostatic force between the electron to the nucleus by the equation Ze square by r square. And then by using this, he succeeded to calculate the radius of the electron, that is the distance between the electron to the nucleus. He calculated, and it goes like this: n square into h square by 4 pi square me square. In all this, the n is the quantum number, that is the principal quantum number, that is the number of shell, and h is a Planck's constant, m is the mass of the nucleus, and e is the charge on the electron. Okay, so in this way the Niels Bohr succeeded. And even if you observe the hydrogen spectrum, he explained the energy levels, how an electron will goes to the higher energy level by taking the external energy, and after some time it will gives back its energy in the form of radiation. And that radiation will goes like this. By the names, the Lyman series, where the electron is been jumping from the second energy level to the first energy level, or even from the third or even from the fourth to the first energy level. Then this radiation he observed in the UV spectrum, or the energy is given in the UV radiation. And then the Lyman series, the Balmer series is the visible region where from the higher energy levels, third, fourth, or from the fifth to the second energy level, the electron will fall, and then it is the visible region. And the radiation will appear in the visible region. And then the bracket, Paston, and Fun, where the electron, when it jumps from the higher energy levels, starting from the fourth, fifth, or sixth to the third energy level, then the radiation will appear in the IR spectrum or IR region. In this way, Niels Bohr clearly explained about the single electron system, that is the hydrogen, how the energy levels are being varying and how the electron revolves around the nucleus. And then in the continuation of this examination, the Sommerfeld proposed that the electron, as the principal quantum number increases, it will become, the orbital of the electron will become more circular. The oval shaped Sommerfeld, the oval shaped orbitals will become circular as the n value increases. So all these attempts, right from the 4th century, all these attempts are being made to know about the atom and subatomic particles. But later on stages, it is so evident that the electrons are been revolving around the nucleus, and the electrons will choose the definite path. That definite path, we are calling it as the orbit. And the space between two orbits are called as the internodal space, where most of the space is empty. So when the wave mechanics are being started or introduced in the year 1920, then the application of wave mechanics onto this subatomic particles has been tremendously gained the experimental evidence showing that the electron revolving around the nucleus, and then theoretically proposed where the orbital is exactly by using these wave mechanics is clearly explained by the Schrödinger equation. Schrödinger is a scientist and he has introduced the symbol called as psi. Psi is the wave function and psi square is the wave function for the orbit. So he explained the wave function based on three-dimensional view, and the wave equation he has been coined by this formula: d square psi by dx square plus d square psi by dy square plus d square psi by dz square plus 8 pi square m by h square into E minus P. P means potential energy into psi is equal to 0. This is the wave equation proposed by Schrödinger. All these are the introduction parts to know how the atom will be and what will be there in the atom with respect to the electrons and to the protons. Quantum numbers. To locate where exactly the electrons are, to locate what the electrons will do inside the atom around the nucleus, these quantum numbers will help us. So we know that we are very much familiar now that the electrons revolve around the nucleus in a definite path, and we will call it as the orbit. So in the quantum numbers, the first quantum number is the principal quantum number. Principal quantum number is being denoted by the small n, and it will tell the shell numbers. That is, it starts with the 1, 2, 3, 4 and so on, or K, L, M, N, so on. So, for an example, for the hydrogen atom, the one and only electron will be there in the K shell, or in the n is equal to 1. So this principal quantum number will give us the information how many shells are there in an atom, and with that we can able to calculate how many electrons are there in the each shell. And then the second quantum number is the azimuthal quantum number, or we can call it as the angular momentum quantum number. This quantum number is being denoted by L, and L starts with the 0, 1, 2, 3 and so on. So this azimuthal quantum number will deals with the subshells or sub-energy levels, we can say. Even we can say these are as the energy levels. Each shell is one energy level. With the same way, the subshells or sub-energy levels are being given by azimuthal quantum number. It is denoted that when n is equal to 1, the L would be 0. That is, it donates the s orbit. Okay. When n is equal to 2, the possibility of L will be 1. That is, it will be the p orbital. And also, when the n is equal to 3, the possibility of L is equal to 2, and that will become the D. So S, P, D, F, that is L is equal to 0, 1, 2, 3. So we can easily know that by using the principal quantum number and azimuthal quantum number, in a shell how many subshells are there, and in these subshells how many electrons can be accommodated. Let's see. In the S subshell, it will have one orbit and it can able to accommodate 2 electrons. And in the P subshell, it will have 3 orbitals, and in P orbitals can accommodate 6 electrons. In the D orbital, it will have 5 orbitals, it can accommodate 10 electrons. In the F subshell, it will have 7 orbitals, in that the 14 electrons can be accommodated. After the azimuthal quantum number, we have the magnetic quantum number. Magnetic quantum number is being donated by M. M is equal to 2L plus 1. So, by taking into the consideration of L value, we can say that if L is equal to 0, then the M will be 1. That is, it donates the S subshell and it will have 1 orbital. If L is equal to 1, the M will be 2 into 1 plus 1. It will be 3. That means it will have 3 values of plus 1, 0 and minus 1. That indicates 3 orbitals. So in these 3 orbitals, we can accommodate 2 electrons each. So that will be 6 electrons. And when the L is equal to 2, So m is equal to 2 into 2 plus 1, that will become 5, and then that goes with the minus 2, minus 1, 0, plus 1, plus 2. So it will have the 5 orbitals. It can able to accommodate 10 electrons. In the same way, when L is equal to 3, the M will be 2 into 3 plus 1, that will be 7, and then it is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3, and these indicates 7 orbitals, so that it can accommodate 14 electrons into it. And then the spin quantum number, the last one, and this spin quantum number will tells us how the electron is being revolving around the nucleus in a clockwise or anti-clockwise direction. If it goes through the clockwise direction, it will be donated by plus half, and if it is going in an anti-clockwise direction, it will be donated by the minus half. So these are all the basic things regarding the atom and the electron and the nucleus.